Fuel injection pumps are the unsung heroes of diesel engines, acting as the precise distributors of fuel at the right time and pressure for optimal combustion. Among these, the model J926887 stands out for its compatibility with multiple case tractor models, including 2555, 2155, 2188, 420, MX200, MX220, and CPX420. Understanding how to select, inspect, install, and verify the performance of this fuel injection pump is critical for anyone looking to maintain or repair their diesel equipment. The link for purchasing this pump is provided below, but before diving into the purchase, it's crucial to grasp the fundamentals of fuel injection pumps and the specific considerations related to the J926887. Diesel engines rely heavily on the precision of their fuel injection pumps. Over time, wear and internal tolerance shifts can cause a decrease in performance. This may manifest as rough idling, difficulty in starting, loss of power, or the presence of excessive smoke, particularly black smoke, from the exhaust. These issues typically signal that the fuel pump is no longer delivering fuel in the exact timing and quantities necessary. At this point, replacing the pump with a high-quality unit such as the J926887 becomes essential. Compatibility is the foundation of a successful replacement. While the J926887 is manufactured to fit several case models, compatibility goes deeper than merely matching the external model numbers. Differences in engine versions, years of manufacture, or submodels can affect the injection system's specifics. These nuances impact the pump's internal components, mounting flange dimensions, drive shaft interfaces, and fuel delivery characteristics. Therefore, verifying the compatibility by cross-referencing the engine serial number and specifications with the pump datasheet is non-negotiable. Internally, the J926887 pump is a complex assembly of plungers, sleeves, delivery valves, return springs, seals, and precision-machined components. The tight clearances between moving parts are critical. Any deviation beyond factory tolerances can lead to internal fuel leakage, inconsistent pressure, or timing errors. Surface finishes and materials play a pivotal role here. High-grade hardened steels with polished surfaces ensure longevity and reliability under the intense pressures and temperatures found in diesel injection systems. One of the key technical specifications to focus on is the pump's flow versus pressure curve. This characteristic curve defines the volume of fuel delivered at various engine speeds and the pressure at which it is supplied to the injectors. Matching this curve to the original pump ensures the engine receives the correct fuel quantity across all operating conditions. A mismatch can cause fuel starvation at high RPM or overfueling at low speeds, resulting in poor performance and increased emissions. Equally important is the mechanical drive interface. The pump's drive shaft's spline count, length, engagement depth, seal face design, and flange mounting pattern must match the engine's drive system exactly. Even minor discrepancies can cause premature wear, leakage, or outright failure. It is advisable to physically compare the new pump with the old one, focusing on the spline count and shaft dimensions, to avoid compatibility issues. Upon receiving the replacement pump, a thorough inspection is warranted. Manually rotating the drive shaft helps confirm the smoothness of the internal mechanism and reveals any unusual binding or play. Examine all ports for proper seal installation and check for any machining defects or burrs that might have occurred during manufacturing or shipping. Some pumps arrive dry and require priming or pre-lubrication before installation to prevent dry starts that can damage internal components. Installation demands attention to detail. Use the correct gasket or sealing surface to prevent leaks. Align timing marks on the pump with those on the engine's drive gear if applicable, ensuring injection timing remains precise. Mounting bolts should be tightened evenly in a cross pattern to the manufacturer's torque specifications to avoid distortion. Proper routing and secure connection of fuel supply and return lines are essential to avoid fuel starvation or air ingress. Air contamination in the fuel system is a common enemy of diesel pumps. Air bubbles cause compressibility, disrupting pressure consistency and injector operation. The fuel system must be bled meticulously. Utilize the pump's priming mechanism, bleed screws, or vacuum bleeding tools to expel air until pure, bubble-free fuel flows steadily. Cranking the engine without starting it helps purge air from injectors and fuel lines. Repeat this process as necessary until the system is completely free of air. Starting the engine after installation should be done with caution.